Hi everyone, here we will discuss about the numerical example for decision tree algorithm. Uh, First, we have to calculate the entropy to create the root. So here we are having the 14 samples. The 14 in that 14 samples, 9 samples are positive class and 5 samples are negative class. So here we are applying the formula is minus total number of positive samples divided by total number of positive and negative samples log base 2, then positive samples, number of positive samples divided by total number of samples in the data set minus then number of negative samples divided by total number of positive and negative samples log base 2 negative number of negative samples divided by total number of samples in the given data set. So here when you are substituting the values, you will get the 0.94, that is 94 percentage of impurity of our data. Here we are having the four attributes. One is outlook, temperature, humidity and wind. So from this four we should select one of the best node that will act as a root. For that we should calculate the entropy to select best node that is acting as a root node to take a decision. Here first we will select outlook. For outlook we will have different values. One is, look at this, outlook is having the sunny with 5 samples, rainy with 5 samples, overcast with 4 samples. So for this we have to calculate the entropy. So first we are calculating the entropy for attribute outlook with the value sunny. When you are taking the samples for outlook equal to sunny, we are having the totally 5 samples. In that 5 samples, 3 samples are negative, 2 samples are positive. So that's what mentioned in this tree. So two samples are positive, 3 samples are negative. When you are substituting the values in that formula, minus p by total number of, here again look at that, this is pi means number of positive samples in the outlook equal to value is sunny, then total number of samples in the outlook equal to value sunny, that is the thing. So minus 2 by 5 log base 2, 2 by 5, when you're substituting the values you are getting the 0.971 when the outlook equal to sunny. Like that, the second value for the outlook is overcast. When you are substituting this, here we are having all the samples belonging to the single class, all are positive class. If all are positive class, you look at here, all are positive class, zero number of negative class. If it is the case, when you are substituting the values for that, pi divided by pi plus qi, that means number of positive samples belonging to the outlook equal to value overcast divided by number of positive samples for the outlook equal to value overcast plus number of negative samples the outlook equal to value overcast. Like that we have to segregate this formula. When you are substituting the values, your entropy value is 0. Then one more value for the outlook is rainy, which is having again 5 samples, 1 2 negative samples, that is mentioned here, 3 positive samples. When outlook equal to rainy, the entropy is here again the positive samples when the outlook equal to value rainy. So here 3 samples, then divided by pi plus qi. I value is here rainy, right? So when you are substituting the values, you will get 0.971. Now we have calculated for entropy of outlook for 3 number of values. One is sunny and rainy and overcast, right? So that using that we have to sell using that we have substituted here entropy of value sunny is 0.971, entropy of overcast is 0, entropy of outlook when value is rainy is 0.971. So total information gain is now calculated here, right? The formula is entropy of S, entropy of S minus entropy of outlook equal to entropy of outlook equal to sunny multiplied with that P by P plus Q, then P by P plus Q, the entropy of outlook equal to overcast, then plus here again number of samples when outlook equal to uh, rainy divided by total number of samples, then entropy of outlook equal to rainy. When you're substituting the values, you are getting the 0.247. So that's what given here. The number of samples when value is sunny, number of negative samples when value is sunny divided by total number of samples in the given data set, then entropy of outlook equal to sunny, plus then another attribute overcast, plus third attribute rainy. When you're substituting the values, information for the outlook, average information for the outlook is 0.693. Then information gain for the outlook is entropy of all the samples in the given data set 0.94. This is calculated earlier here. This is calculated here. So 0.94 minus entropy of that is information, average information of outlook, that is 0.693. Finally we are getting 0.247. Now like this we have to calculate the entropy for humidity. The humidity is again calculated. Humidity is having two values, so one is the high and another one is the normal. Under the high we are having 3 positive samples, 4 negative samples. So for that, when you are substituting the values, you will get the entropy of humidity equal to high. Humidity is when high 0.985. Then when humidity is normal, we are having the 6 positive samples, 1 negative sample. So when humidity is normal, our entropy of the humidity is normal 0.592. Then you have to calculate the average information, uh, which is given by the humidity is, we have to calculate it here. Then the information gain is 0.94, that is uh, entropy of given data set 0.94 minus the average information gain from the humidity, so which is 0.151. Likewise, third attribute is wind. For that, this is the total number of samples entropy 0.94. Here wind is having two values. One is the weak, which is having 6 positive samples and 2 negative samples. Then another value is strong, which is having 3 positive samples and 3 negative samples. When wind is weak, entropy of wind then 0.811. When wind is strong, entropy is 1. Then average information is calculated for the wind is this one. Then we are subtracting the average information calculated from the wind with entire data set entropy 0.048 for the information gain wind. Then fourth attribute is temperature. So temperature is having three values: hot, which is having the 2 positive samples, 2 negative samples; mild, which is having 4 positive samples, 2 negative samples; cold, which is having 3 positive samples, 1 negative samples. When temperature is hot, the entropy is 1. When you substituting the values, entropy is 1. When temperature is mild, the entropy is 0.911. When entropy is cold, when temperature is cold, entropy is 0.811. The information received from the temperature is this one. Then we are subtracting the values. Finally, entropy of temperature, information gain of temperature is 0.0291. So now we are taking all the four attributes information gain: outlook 0.247, humidity 0.151, wind 0.08, temperature 0.029. So now we have to select the maximum information gain value. So here the maximum information gain value is 0.247 among these four items. So this will be acting as a best attribute to take the decision. So outlook is selected as a best attribute. So here the outlook is selected as a best attribute. So this is the root node, right, for the given tree, because this is the first attribute is selected as the best one, right? So here which is having the three values: sunny, overcast, rain. Now here under the overcast, so what are the samples available under the sunny? I have given the number d1, d2, sample number 8, sample number 9, sample number 11. So these are the samples belong to the sunny when belong to the outlook equal to sunny. Data point 3, data point 7, data point 12, data point 13. Four samples belonging to the outlook equal to overcast. Then data point 4, 5, 6, 10, data point 14 are belong to the outlook equal to rainy. So in this five samples, three are positive, two are negative. Two are negative. But here in the overcast, all samples belonging to the single class. So hereafter there is no need of any split. But here we are having two positive samples, three negative samples. Here three positive samples, two negative samples. So which attribute is next best attribute among the remaining three? Remaining three are wind, temperature, and one more is humidity. Among these three, which attribute will contribute more to take best decision? So first again repeat the same process for constructing subtrees. We are taking the first subtree with value sunny. So we are taking the outlook equal to sunny. Here we are having five samples. So these are the five samples. Here three are negative, two are positive. So here which attribute will give you more information gain? For that, first we have to calculate the entropy when outlook equal to sunny. Here two positive, three negative samples. When you are substituting the values into the formula, we will get 0.97. Then we have to take the attribute one by one among the three: humidity, temperature, and wind. First we are selecting the humidity. So when outlook equal to sunny, what are the possible values for humidity? What are the possible values of humidity? Here the sunny outlook equal to sunny and humidity is high. There is no possible of playing the tennis. And when outlook equal to sunny and when outlook equal to sunny and humidity is high, no possibility playing the tennis. When outlook equal to sunny and conjunction and humidity is normal, there is the possibility of playing tennis. Yes. So when humidity is high, right? When humidity is high and outlook equal to sunny, what is the entropy? Zero. When outlook is sunny and humidity is normal, entropy is zero. Now average information entropy for the humidity is zero, and finally information gain when outlook equal to sunny and humidity 0.97. The remaining two attributes are wind. First one is wind. We are selecting when outlook equal to sunny and wind is weak. There is no possibility of playing the tennis. When outlook equal to sunny and wind is weak, there is possibility of playing tennis. Yes. And you look at the third example: when outlook equal to sunny, wind is weak, there is no possibility of playing the sunny. So here we have to check how many yes and no. So three negative samples, two positive samples. So when uh, outlook equal to sunny and wind is strong, entropy is 1. When outlook equal to sunny when and wind is weak, entropy is 0.8271. So when you are substituting the values, information gain when outlook equal to sunny and wind 0.0738. Then third one, we are selecting the temperature. Here when outlook equal to sunny and temperature equal to hot, no possibility of playing the tennis. When outlook equal to sunny and temperature equal to mild, no possibility of playing tennis. When outlook equal to sunny and temperature equal to mild, playing possibility of tennis, yes. So substituting the values, you will get the information gain 0.571 when outlook equal to sunny and temperature. So now we are comparing which one is contributing more information gain. 0.97 is contributing more information, so which is selecting as a best attribute, which is selecting as a best attribute. So now already root is selected outlook. Then when value is sunny, right, among the three attributes humidity and temperature and wind, humidity is contributing more. So after when outlook equal to sunny, the humidity is the next node which is taking the decision by acting as a best attribute. The humidity is having again two values. You look at here, humidity is having two values here, high and normal. High and normal. Whenever high, there is only samples with the single class. You look at that, all samples are belonging to single class. No. When normal, all the classes are only positive class. All samples are positive class. So when normal, all are positive. When high, all are no. So now there is three samples belonging to the humidity high. And so this means you look at that, when outlook equal to sunny and then humidity is high. So in this case there is no possibility of playing sunny. This is the meaning. And when outlook is sunny and humidity is normal, then there is the possibility of playing tennis. So here two samples are contributing, here three samples are contributing. This is the meaning here. Next, here we have to repeat the same process for this path rain. So outlook equal to rain, we are having three attributes: temperature, humidity, wind. So here how many samples are positive? Three samples are positive, uh, two samples are negative. So based on that, we are calculating the entropy for the value rain. So we are getting the 0.971. So likewise, when outlook equal to rain, we are checking the humidity attribute. So when outlook equal to rain and humidity is high, there is possibility of playing the tennis. When rainy and humidity is normal, there is no possibility of playing tennis. So here we are having three positive samples, two negative samples. So based on that, when outlook is rainy and humidity is high, entropy is 1. When outlook is rainy and humidity is normal, entropy is 0.8271. Then based on that, average information is calculated for humidity 0.896. Finally, we are calculating the information gain for the outlook equal to rainy and humidity. Okay, so 0.075. Then for the temperature attribute, we are calculating here when rainy and temperature is mild, playing tennis, yes. When rainy and temperature is mild, playing possibility. When rainy and temperature is cool, no possibility. So when you are substituting the values, temperature is hot, there is no sample for the value hot, so 0 entropy. And mild, when mild we are having three samples. When the mild we are having the three samples. So in that three samples, so three samples are this one and this one first sample, fourth sample and fifth sample. Among this, two yes and one no. So that's why we are having two positive samples, one negative samples. We are calculating the entropy 0.8271. Here it is given clearly. And when temperature is cool, one number of positive sample, one number of negative samples, entropy is 1. So average entropy of temperature is 0.896. Information gained by temperature is 0.075 when outlook is rainy. Then we are selecting the wind when rain is when outlook is rain and wind is weak. Yes. So here when wind is strong, the zero number of positive samples, two number of negative samples, entropy is 0. Then wind is weak, three number of positive samples. So you look at that, wind is weak. Okay, three samples are there. Among these three, two are three positives and zero negatives. So entropy is 0. Then we are substituting the values. Finally, we are getting the entropy 0.971. So among this three, maximum value is 0.971. So which is selected as a best attribute under the outlook equal to rainy. Under the outlook equal to rainy. So now you look at that, under the outlook equal to rainy, wind. Okay, wind is selected as best attribute to make the decision. Here wind is having two different values. You look at here, wind is having two different values, weak and strong. So when the wind is strong, how many samples are no? You look at here, when wind is strong, both are no. So both are belonging to no. 6th sample and 14th sample. And when wind is weak, all the samples are belonging to positive class. So all the samples are belonging to positive class. So three samples, 4, 5, 10. Now you look at that, among the 14 samples, all are classified into single class. Here these three samples no, and next one here these two samples are yes. Here two samples are no. Here two samples are yes. Here all the four samples are belonging to yes. So all the samples belonging to any one of the class yes or no. So if all the samples are classified into yes or no, we can stop the algorithm and return the tree with root node. So this is the id3 algorithm. So whenever we are having the attribute and discrete valued functions, target function, then we can use the id3 decision tree algorithm, and which is maintaining only single hypothesis and output only the single hypothesis, right? And there is no backtracking on the selected attributes. That is one of the disadvantage here. And which is statistically based search sizes, which is robust to the noisy data. That means it can handle the error and missing values easily. So with this, I conclude the decision tree id3. Thanks for watching.